Hello guys, today I'm here to talk about Merkle trees, Floresta, and BDK. I'm Luis, I'm a grantee from Bitcoin Dev Kit, based out of Brazil. So a little overview on BDK. We are a library with a set of crates for building layer 1 Bitcoin applications, mainly wallets. But like you can build anything that touches on-chain. We care about blocks, transactions, and how to retrieve them. So we have a few crates on BDK. We have our main crate, the BDK wallet, which is a fully fledged wallet implementation, batteries included. We have BDK core, which has the core types and structures that we build everything on top of. We have chain, which indexes relevant chain data to the wallet's SPKs. We have the file store, which is a file database for testing and development. We have the test-env crate, which is a set of utilities to make integration testing and things like that. We have the Electron client, which connects to an Electron server. The Explorer client that connects to an Explorer server. And Kyoto, which is a chain source crate that uses compact block filters for data retrieval. So the wallet implements the BDK wallet crate implements the wallet structure. It tracks, indexes, and updates SPKs from the descriptor. These updates need to come from somewhere, either a Bitcoin node, an Explorer, or Electron. So this is an issue because most people don't really want to run a server or don't know how to run a server. So they just have to trust whatever data they get, and there's not much they can do about it, So these servers are a very big honeypot for malicious actors like states and ISPs and whatever, because they can correlate your IP with chain data, such as transactions, addresses, balances, and things like that. So now we get to the issue of the UTXO set. A UTXO represents an unspent transaction output, a coin that can be spent. Everybody on the network needs to be aware of everybody else's coins in order to validate transactions. So if you want Bitcoin to scale on layer 1, we're going to have a lot more coins than we have now. Because Bitcoin is very small, very few people use it. So if you want to scale this to the entire world, we need to figure out a way to make this scale. We can see on this graph that the UTXO set is ever increasing. It has doubled since the last 2 years. So it would be great if we could figure out a way to compress that. And we can with Utreexo. So Utreexo is a scheme that manages to compress the UTXO set into a compact representation using a dynamic hash accumulator. It does that by arranging all the UTXOs in the set as leaves in a Merkle tree, hashing them, and storing only the roots. So we can compress 11 gigabytes of UTXO set into just a few hashes. Since we compress the UTXO set, we're not aware of its entirety. So we need a way to prove that a coin is present in the set without knowing the entire set. So we have inclusion proofs. Let's say I want to prove that the coin C is in the set. For that, I need to prove hashes HD, HAB, and HEFH. You can check this inclusion proof against your own accumulator state and verify that the coin is indeed present in the set. So Utreexo introduces some new network topology to the Bitcoin network. We have full nodes, which are just regular Bitcoin Core nodes. We have a bridge node, which is responsible for generating and providing all the proofs. So instead of just storing the accumulator hashes, it stores all the trees. So that's a bit heavy, a few tens of kilobytes on gigabytes on mainnet. We have compact state nodes, which are nodes that only store the Merkle root hashes. And the bridges provide proofs to compact state nodes. So Floresta is a Rust implementation of a compact state node. It's a lightweight node that can run on a phone or even a Raspberry Pi. It has a reusable set of crates that can be used as a dependencies for other projects, such as bdk-floresta. So now we have Floresta as a chain source for BDK. Why? I think like BDK has a lot of users. Many projects use BDK to implement wallets. So it would be great if they could have a drop-in replacement that has local trustless on-device validation. Because making API calls with foundation information is bad for privacy. So basically, bdk-floresta will spawn a Floresta node on the background, and then it exposes a subscriber that emits wallet updates that can then be applied by the wallet. Currently, as the project stands, we only have block-by-block synchronization, which is, as the node receives a new block, it's applied by the wallet, which takes some time. But soon, we're going to have compact block filters implemented, which will be able to do a backwards full scan very fast. So spawning a node is pretty simple. We create some configuration for the node, like network and data directory, user agent, and things like that. Then you build a node with the configuration. And then you just have to get the updates from the node. So you get a lock on the wallet. You create a subscriber from the node. You spawn a process that will listen to new events. And then you match against the event type. Currently, we only have block events. So the wallet applies the event. And that's pretty much it. I made a demo on Signet, so let's see if it's going to work on this network. So it spawns a node, fetches some peers from DNS. Downloads the headers from peers. So we need to get some more bridges up. Yeah. Yeah, it's trying to connect to a Utreexo peer, a bridge, to get proofs to validate the blocks. So yeah, it just spawns a task with Tokyo. Yeah. I mean, there are a few in Brazil, some in the US, but we need more. Yeah, that's a problem because there's like so few bridges that the chance of finding a bridge via P2P discovery is very low, you know.
Okay, so you need more people to run bridges,
Yeah.
and then we'll get the peer-to-peer discovery better.
Do you do preferential peering?
Yeah. Yeah, it seems we're having a lack of bridges here.
And this, those bridges are developed where? Like, does Floresta develop a bridge as well, or is that a completely separate piece of software?
State node, so it only keeps the stubs from the roots. There is another project that's a bridge from Calvin Kim, which is UTXOD. So this is what people are running pretty much.
I see. And UTXOD is only the bridge, or they also have a compact node, do you know?
I think they can run as a compact node as well.
Okay.
But I'm not sure.
Okay.
Yeah. It looks a little focused. There we go. So I had a question about like the privacy trade-offs point that you were making. So like, you know, typically you might be connecting to some kind of external, you know, Explorer instance or something. But with this, are you going to be connecting to like a very small set of these bridge nodes? And is there any difference in the kind of, you know, information we're asking for?
So you only like really need bridges during IBD. After IBD, you can connect to other compact state nodes, and they will have proof for like new blocks and transactions. You only need a bridge for IBD. Like you behave on a network like a normal node.
I just like to add that the difference here is that you are a regular node doing regular node stuff. So you're just downloading blocks and transactions, address, things that an address, like any node would already do. So you are just a node rather than this is my address, giving me my transactions. So it's pretty different. You're just a node doing node stuff, but with people know you are a Utreexo node, but that doesn't give much away. It's just like, hey, I do Utreexo, nice to meet you. But you're not saying, here's my address, what's my transactions.
Yeah, exactly. So like if you broadcast a transaction via an Explorer server, the server knows the transaction is yours. You can like correlate with your IP. If you're using a embedded node, like it can be anybody's transaction. You're just relaying the transaction. So there's a big privacy gain there. Yeah, it seems we're not gonna have this demo working today.
Can I follow up on what you just said before? Did you say that you don't need the bridge, but I thought you said that the bridge makes the proofs for every new block that comes along?
Yeah, so Utreexo works like this. If you want to spend a UTXO, you have to attach an inclusion proof of that UTXO in the set. So let's say I am a compact state node, like Floresta, and I want to spend a UTXO. I need to have the inclusion proof for that with me. So I create the transaction, sign it normally, attach the proof, and broadcast it. No? Yeah, so since we're not going to have any demo working, I'm going to do like a walkthrough on the code. So this is the example I'm running. We have a descriptor, which I deposited some Bitcoin to it. We create a BDK wallet, set the descriptors, set the network. We can do assume valid, which means you don't do script validation for blocks before this one. So that goes a little faster. You create the node config. You have a set the network, set the data dir, and some other fields if you want. Then you create the node. You spawn a node with the config, with the assume valid, attach the wallet, build. Here I connect some bridges manually, but apparently that's not working. Then you create a wallet subscriber, so you can listen to new wallet updates from the node. Then you spawn a task for receiving these updates. And then you can match the update variant and apply it to the wallet. So in this case, it's a block. So BDK already has an API to apply the block directly, so we don't have to do anything. But in the future, we're going to have wallet updates from the compact block filters. So here we have the implementation of the node. We have config, we have the chain state. We have a handle to interact with the node. We have some SIGINT tasks. We have a signal to stop the node. We have the wallet, and we have the subscriber, which is just about the receiver. Here we have some methods to interact with the node, like shutting it down. This checks if the node should stop. Disconnects a peer. Disconnect a peer. Get some info about the peer. Here we have implementation of the block subscriber. Here we can flush the chain to disk. Some other stuff. Here we have the builder for the node. So we have to configure all of these things. So like this project is still in its infancy. We still have a lot of work to do both on Floresta and on BDK. So I have like 1 foot on each project doing some stuff. We wanna like couple the node better with the wallet, so we can have a shared persistence layer. We have some stuff to change on BDK chain as well. But yeah, I think that's pretty much it. If you guys have any questions.
Yes. I'd like to ask how an ordinary pleb who's not a coder might be able to run a Utreexo node.
I mean, you don't really need to know how to code. You can like just clone a repository and install the binary, and that's it.
Actually, I'm thinking about the bridge node.
Yeah.
Yeah. Because it looks like
we need to get a lot more of those out in the wild.
Yeah. You probably need a VPS. Probably need a VPS to run the bridge.
Oh, okay.
We need
right. Okay.
People need to be able to access it. You know?
Yeah, yeah.
It needs to be public.
Yeah. Okay. Thanks.
I have two questions. My first one is, how heavy are these bridge nodes? Like, could I just, potentially run it alongside my Bitcoin node, or could it ship on a start 9?
Heavy.
What's that?
They're kind of heavy,
They're heavy. Okay.
They use up a few tens of gigabytes of RAM because they need to keep the whole forest in RAM.
Okay.
So.
Interesting. So that might be hard to just ship on a umbrella or something where people can just click play and
that's very feasible. It's very hungry.
Yeah. Cool. I saw the presentation yesterday on having it on mobile, or 2 days ago. Yeah. So yeah, that was great. Looking forward to seeing it in BDK. And my second question is, how many people are working on Floresta on the project, and how's that going? Are you looking for contributors?
I'd say there's 5 people. 5, 6 people. Yeah.
Awesome. Thank you.
Do you have questions?
Hi, can you explain how compact block filters integrate with that? Has it something to do that it can also fetch the relevant information from normal Bitcoin nodes and not only from Floresta nodes?
Yeah, so the way it's implemented at this moment, we can only get wallet updates from new blocks that the node verifies and receives. But the problem is, if I have a wallet that has transactions in the past, I cannot really sync them very fast. So if you have compact block filters, compact block filters work with Bloom filters. So we make requests to many peers with this filter, and we get the transaction details that we care about.
So only during IBD you do compact block filter fetch?
No, we do compact block filters after IBD. But Floresta can also skip IBD, so in this case, the only way to get updates from the past is to do compact block filters.
Thanks.